Okay. Okay. All right. So halfway through this lesson is L'Hopital's rule. Thank you, Julian. Appreciate it. The reason you don't have examples 1 through 4, FFA people, is because your classmates forgot to press play. So we'll pick up with example 5.
Just put a 1 in that number 9.
L'Hopital's rule. Put a what?
Put a 1 instead of 5 in the number
2
9.
Oh yeah, we'll just call it example 1. Pretend. We'll just pretend.
Yeah, there we go.
Okay. So L'Hopital's rule. If we were to try to input 0 here, e to the 0 would give us 1 minus 1. And you input 0 there, and you get 0 over 0. And this, again, is called that indeterminate form. So we would apply L'Hopital's rule and take the derivative of the numerator. What is the derivative of e to the 3x minus 1?
3e to the 3x.
3e to the 3x. Good. And then the derivative of x is just 1. And L'Hopital's rule tells us that the limit of this will be the same thing as the limit of that. So if you input 0, which is just 3 times 1 over 1. So this limit is 3, and therefore the original limit would also be 3.
Does that ever get like much harder than this?
No, sir. L'Hopital's rule is a simple concept.
It does have some truth.
Add some trig.
Shoot, no.
No.
Example 6.
You're just joking about the trig, right?
No. Example 6 is really a trig problem. Y'all know me
Much harder.
so well. It's not.
Arctangent of 28.
Really it is. Much harder. Okay, so if we input 0, tangent of 0 is going to give us,
No, don't tell us the answer.
you know tangent of 0.
If I get the flu, I'm coming to class.
Oh, thanks. I appreciate it.
It's
I'm going to sneeze all in your car in the morning.
secant squared of it. Is that right?
Well, first of all, we have to find out if I can just do direct substitution. What's tangent of 0?
0.
Minus
0.
0 over
0.
Okay, so the first thing you have to do is make sure L'Hopital's rule applies. Now, y'all, L'Hopital's rule does not apply to every quotient, only the ones that give you the indeterminate answer. So only the ones that are 0 over 0 or infinity over infinity. Okay?
Ask what was the derivative.
Now let's take the derivative. So the derivative of
Squared.
tangent of x is secant squared of x minus 1 over 3x squared. Okay, what is the derivative of secant? Not derivative. What is the value of secant at 0?
1
Over cosine, which is
So 1 over 0.
1 over
So
negative
1 over
1.
Isn't that 1 over 1?
Oh yeah,
Well,
well,
1,
Oh, yeah.
1 minus 1.
Minus 1?
And then be 0 to the bottom. So you get
Okay. So yay, you get to brush up on your trig derivatives, and you're going to take the derivative again. The limit as x approaches 0. Now,
secant tangent.
and we have to use chain rule, right?
2 secant tangent.
2 secant x to the 1, and then times secant x tangent x over 6x. Can we go ahead and shorten that to 2 secant squared of x tangent of x over 6x? And we're still taking the limit. What was secant of 0?
Zero was 0.
Secant of 0 was 1, but tangent of 0 turned out to be 0. So this is going to turn into 0 over, again.
Yeah.
Now, in the next form, are we going to get 0 over 0? No, because that denominator is going to turn into just 6. So now we need to take the limit,
Dang, now we gotta do product.
and now we get to do product rule and chain rule.
I'm very alive.
That'd be 4.
Give me 6, please.
You don't get that much harder.
No, till we put trig in it. So we get 4. We're taking the derivative of this first half.
Yeah.
4
4
secant x times
secant tangent.
secant x tan x times the second original function tan x plus,
That'd be derivative of.
now we keep the 2,
That'd be 2 secant squared times the derivative of tangent x, which is secant squared.
which is also secant squared. Nice. So let's simplify this, and then we'll try to substitute 0 and see if we can get an answer this time. So I get 4 secant, good,
Times tangent
good,
plus 2 secant cube.
cube
Oh, wait, no, to the 4.
to the 4th, good, all over 6.
Bennett, you knew the answer to this before we started.
Bennett asked for it. So when you put in 0 for secant, we get what? 1 times,
0.
okay, so this is 4 times 0 plus 2 times 1 over 6.
Oh. Alright, so wait, what?
Remember, this value is 0.
So
Is it 1/3?
Yes.
over six.
This value is 1.
Yeah.
This value is 1.
4 times 0 plus 2 times. Yeah.
Is 2 6? Yes, sir, 1/3. Okay. Easier to what?
Easy calculator, yeah.
If this were on a graphing portion of an assessment, wouldn't you look at that function in the graph
Yeah.
and see what is approaching at 0 and trace it and get closer and closer and closer to 1/3?
Heck, yeah.
Okay, all right. So, for those of you that missed the first examples, here they are. There's the first one. Copy real fast.
Don't trust her. She says it's easy, but it's not.
Don't listen to Josh. There's the second one. And there's the third one.
She's very deceiving.
Hope the farm show was fun. Here's the fourth one.
Oh, calculus.